So what are we doing the engine development for? There is a NASA prize for building a nanosat launcher, which is a vehicle that will launch a 10-centimeter cube of 1 kilogram to go around in orbit at least twice, and we're going to pursue that prize. The goal being to eventually develop a nanosat launch capability that can be resold commercially. I mean, currently people are paying as much as $500,000 to get a 3U nanosat launched, and I think you could make a business case for doing 4 or 5 of those a year at a price significantly less than that. You know, $250,000 a launch as opposed to $500,000 a launch, where they get to choose their launch site and time. There's a chicken and the egg problem with orbital launch, i.e. it's so expensive and it takes so much to develop the satellite that you can't really do anything risky, i.e. space is not cutting edge technology. Space is 20-year-old technology because nobody wants to take the risk with a, you know, $100 million or $1 billion program. So one of the long-term goals is to make it so it's a $250,000 program to launch something and try something, and then you can try things. You know, maybe the business case doesn't work. Maybe the technology doesn't work. But you'll never know till you try. So, I mean, the long-term goal is to create a viable business that isn't just driven by government. You know, because right now all the, you know, once you start getting in the government accounting procedures and cost plus accounting and, you know, the bureaucracy paralytic poison into the system, then it's hard to be, you know, lean and commercial. And so we'll see how well Elon and SpaceX fight that. The competitors in this space have been very good about sharing and good sportsmanship and sharing of information, and we're all friends and we all know each other and we're all on good terms. And I mean, like the Maston group all came out and watched my flights. I went and watched some of their stuff. You know, I know basically everybody on the Armadillo team by a first name basis, and they all know who I am, and we, you know, we'll go to Space Access and we'll have a drink at the bar and we'll be friendly and we'll swap stories and we'll swap advice. And we don't see it as a zero-sum game. You know, everybody wants everyone to succeed, because the more one succeeds, the more everybody looks viable, the more business opportunity there is for everybody. I was talking earlier, I gave a speech on why getting to space is hard, right, and the difference between getting to, quote, space, like Spaceship One did, or like Virgin Galactic is going to do, or any of the suborbital people are, and getting to orbit. It's a very different thing. It's, you know, somewhat of a technical difference, but if you've ever played tetherball, you ever play tetherball where you hit the ball around the pole? Okay, well, the Earth is the pole and going around is orbit. Well, going to space is just how far are you from the pole. If you just push the ball straight out, you can get to space, but as soon as you let go, it falls back down. You have to go a lot faster to get it to go around and not come back and hit the pole. And so that's why getting to orbit is about 25 times harder than getting to space. I mean, that's why, you know, while Virgin Galactic or X-Core or Armadillo or Maston are going to take people or payloads to space, they are not taking them to orbit, and there's a huge difference. I mean, anything that goes to orbit has to look like a gas tank because of the physics involved. Yeah, 25 times more energy to get to orbit. So yeah, 2,500%. Well, none of the suborbital commercial ventures have a path that makes sense to get to orbit. Now, SpaceX clearly has gotten to orbit. Their rockets look, surprise, surprise, like rockets. And they're mostly fuel tank. Surprise, surprise. Physics is kind of that way, you know. It sets the rules for everybody, and they're the same. You know, the physics aren't different for the Russians and the Americans. We have to bow to the same realities. Yeah, the Russians have chosen a different path. Their vehicles burn about 2 or 3 times as much fuel to get the same payload to orbit, but they produce them cheaper. And as Elon has quoted for SpaceX, the fuel cost for a launch is almost in the accounting error budget. Imagine how expensive a flight to England would be if you threw the 747 away when you got there. You know, that's what we presently do with space launch. Nothing is reusable, and all the technology is derived from weapon systems, missiles. where, you know, it really doesn't, you don't really make any sense to reuse the nuclear missile after it's delivered its payload. And so we're in the situation in space where we don't get much reuse. The one real serious attempt at reuse, the shuttle, was such a boondoggle because of the cost plus accounting and the various and sundry political factors who said, oh, you must have a, you know, a presence of solid motors from Utah, and you must have pieces here, and you can't be bigger than fits on a railroad car, and you must have, you know, thousands of miles of cross-track glide range for the military, and et cetera, et cetera. You know, it's a, you know, what's the difference between a mouse and an elephant? Well, an elephant is a mouse designed by a committee. You know, you just stick all this stuff on it and it turns into an elephant.